What if tomorrow a black hole appeared in our solar system? One moment the night sky looks normal, the next, stars bend and twist around a dark, invisible predator. If that predator had any sizable mass, gravity would drag our planets out of orbit. Asteroids and comets would accelerate toward the sun. And if the black hole was even close enough to Earth, it would bring nothing but certain doom. But there's a question that haunts me about this scenario. Is the appearance of a black hole nearby really the disaster we'd imagine? Maybe, depending on where it formed and how big it was, a nearby black hole could be the greatest catastrophe in human history, or our ticket to becoming a multi-planetary species, or even more. In our latest episode, we asked viewers which impossible scenario they wanted to see us tackle next, and many of you chose this one. So thank you. This is for you. And as always, we'll put some of your suggestions to use in future episodes. So let's start at the beginning. First things first, how would we actually see a black hole coming? Well, thanks to their extreme gravity, black holes affect anything that gets too close, including light. As stuff falls into a black hole, the intense gravity makes it speed up and heat up, creating a bright point of light that shines from just beyond the event horizon. It's called the accretion disk. As objects like rocks and dust get too close to the event horizon, the gravity difference between their front and back halves pulls them inward. We can watch the material in these disks glow with radiation and heat up as it spirals into the black hole. This glow could alert us that something dangerous is out in space. Black holes come in a variety of masses. The smallest ones are called stellar mass black holes, which are typically just a few times heavier than the Sun. These form when giant stars collapse at the end of their lives. Stellar mass black holes can range from a few kilometers to dozens of kilometers across. But despite their relatively small size, they can spin up to thousands of times faster than our Sun. That speed gives them a tremendous amount of energy. If one came barreling into our solar system, the first thing we'd notice is a slight change in the positions of the outer planets. Uranus, Neptune, and Pluto would all be affected by the gravitational pull of the interloping black hole. For comparison, Pluto is 39.5 astronomical units, or AU, from the Sun. 1 AU is the average distance between the Sun and Earth, or about 150 million kilometers. A black hole half a light year away could easily be detected by its effect on the Kuiper belt objects. The asteroid belt between Mars and Jupiter would also respond to the intruder, and the asteroid belt is much closer to Earth. If humanity had advanced telescopes capable of peering into the depths of space, we'd probably spot the telltale accretion disk around the black hole's equator. And once we saw that, we'd know we had to act fast, because as the black hole approached, its gravity would start messing with our orbit. You see, Jupiter is our planetary bodyguard. Its massive gravity keeps the asteroid belt from getting too close to the inner planets. But if a black hole came along and disrupted Jupiter's orbit, those asteroids would be flung toward us. And while some may burn up in our atmosphere, others could slam into Earth. Then there's Saturn. Its iconic rings are already fragile and easily disturbed. The delicate balance of ice particles and rocks that make them up would disintegrate in a black hole's gravity and scatter like cosmic confetti. Finally, Earth itself would feel the effects. In fact, it would be much worse than the other planets because, unlike those gas giants, Earth is a solid body. Its orbit is set not by volume averages, but by precise paths. If the black hole was even as small as a city, its gravity could drag us into a new orbit, potentially freezing or boiling our world long before we ever reached its event horizon. And here's why. Black holes warp space and time, distorting the paths of anything that ventures too close. Anything that strays too far from its course could either plummet toward the center of the black hole or be thrown into a chaotic orbit around the Sun. It's called the spaghetti effect or spaghettification. That's because as the gravity on one side of Earth's orbit is significantly stronger than the other side, the planet would literally stretch and tear. For perspective, the force of gravity near a black hole's event horizon can be billions times stronger than the Earth's gravity. So let's say the black hole was smaller than our sun, but still twice as massive. If it took up a home in the asteroid belt, it would mess up Earth's orbit within just a few days. Its gravity would stretch our planet until it resembled a thick noodle. If the black hole was bigger than our sun, Earth wouldn't stand a chance. It would be ripped apart within minutes. Of course, we have no control over a black hole, so we couldn't move it. Our only hope would be to nuke it, but that wouldn't work. The black hole's incredible density means it has a huge amount of gravity. That gravity would prevent any nuclear weapons from reaching its event horizon. In other words, we'd never be able to kill the monster directly. So now we have two possible outcomes. If the black hole was relatively small, we might be able to keep it out of our solar system. If it was massive, we'd have no choice but to flee. But is there a third option? Could we harness the power of a black hole? It sounds crazy, but hear me out. A black hole with an accretion disk could provide Earth with more energy than all the stars in the night sky combined. It all comes down to a black hole's event horizon, which is the boundary around a black hole beyond which nothing can escape. Everything that passes the point of no return gets pulled into the singularity at the center of the black hole. The stuff that doesn't fall in immediately forms an accretion disk around the black hole, heated to unimaginable temperatures by friction and gravity. And if we could safely harness the energy of that disk, it would solve our energy problems forever. But how could we possibly extract energy from such a volatile place? Well, researchers are working on ways to safely siphon off some of a black hole's energy. One proposal involves sending tiny probes into the accretion disk, where they would quickly heat up to millions of degrees Celsius. They would generate immense amounts of power, but they'd need to be replaced constantly because the intense heat would melt them in mere seconds. Another approach uses giant mirrors to focus the light from the accretion disk onto a receiver. Because black holes rotate, their accretion disks wobble a bit, making the light flicker. By taking advantage of this flickering, we might be able to collect usable energy without getting too close to the black hole. And that brings us back to the original question. Is a black hole in our solar system a disaster or a blessing? Well, it depends. If the black hole was massive, its gravity would rip our planet apart long before we could harness its power. We'd need to flee our solar system, possibly becoming an intergalactic refugee species. But if the black hole was small enough, we might be able to survive. In fact, we could thrive. Imagine having an almost unlimited supply of clean energy to power our lives and propel our technological advancements. With a little ingenuity and a whole lot of luck, humanity could tap into the power of a cosmic monster and become a true interstellar powerhouse. So what do you think? If a black hole appeared in our solar system, would it be our end or our beginning? Drop your thoughts below, smash that like button if this blew your mind, and subscribe for more impossible scenarios. We're exploring the unbelievable again tomorrow. Thanks for watching.